In this video, we're going to talk about the antiderivatives of the hyperbolic functions and also the inverse trig functions. You may not actually have covered this in your course. Different Calc 1 courses cover it at different times, but some other Calc 1 courses don't include it at all, and it's included in Calc 2. So if this is not in your course, I strongly suggest you just skip this video and go down to the description and then click on the next video, which is a continuation of the non-hyperbolic and non-inverse trig function problems that we're dealing with. We're going to move into integration for the indefinite integral and the substitution properties and methods to solve those types of problems, more complex ones than we've done in the previous two antiderivative videos. So like I said, if you have not been dealing with hyperbolic functions and inverse trig functions and it's not on your syllabus, go to the next video. Okay? Now, in my opinion and in my experience, these functions with the hyperbolics and with the inverse trig are actually used later in the calculus coursework in other ways that we're going to integrate. But for the purpose of this video, we're going to stay to the ones that just have an x, like an x squared or 1 over 1 plus x squared. We're not going to be doing ones that in the past have needed the chain rule to take the derivatives of. We'll tackle those in the next two videos, having to deal with taking an integration and indefinite integral in that case of things that are more complicated, where maybe you have a 4x instead of an x, or a 4x squared plus 3x all together squared. So these are still really strictly very simplistic ones. Now, if you've forgotten how we took the derivative of these inverse trig functions, this is where we're starting. You might want to go back into the series where we're talking about derivatives and find the video that talks about the inverse trig functions. I think I'm going to include those in the description if I can get them to fit, but if not, go back to that video and we'll deal with this. Now, what you're looking at is you're looking for patterns. So, for instance, if you saw something like 1 over the square root of 1 minus x squared, you would look through this pattern and go, okay, that would be the derivative of the inverse sign. So let's get started with just that. And you'd have, if I tell you that f prime is 1 over the square root of 1 minus x squared, you look through these patterns, and your teacher may have let you have a formula sheet where they give this to you, or your teacher may require you to mentally memorize these. So whether it's a mental list or a written on a piece of paper list, you scroll through these and look for the right pattern, right? And you go, all right, that would be for the antiderivative, which is to reverse taking the derivative. That would have said I must have started with the inverse sign, because the derivative of that is 1 over the square root of 1 minus x squared. Don't forget the plus c. If you don't add the plus c, because remember that's a constant of integration, then what you've done is you have said there's only one possible solution. And remember, we have a whole series of family functions that are just transformed by either raising them up or lowering them down. So unless you have information to find c, you have to put plus c on there or it's wrong. All right. So let's try another one. So if I tell you I took the derivative of something, I ended up with 2 over the absolute value of x times the square root of x squared minus 1. And you look through here and you go, well, okay, I can find this x. And remember, when we first did these, we had restrictions on the domain, so we didn't need to put the absolute value in there. So here's the absolute value of x, here's the square root of x squared minus 1, but there's a 1 on top, there's not a 2. So you could rewrite this as 2 times 1 over the square root of x minus 1 times the absolute value of x. Now, factoring out this 2, you may not need to do that. You could see it as just the 2 times an understood 1 right here. But I'm trying to help you learn how to look for patterns and make the patterns show up, because what we're going to do when we do the substitution method is you're looking for patterns, and then you have to figure out how to make the pattern actually visible instead of maybe hidden in something. So it'll make more sense in the next video. All right, so here we go. So we go, this is 2 then, and 1 over the absolute value of the square root of x squared minus 1 is the inverse secant of x. Don't forget the plus c. The other error that I sometimes see from students is they forget to change from f prime to f, or worse yet, they just sit there and say, all right, I'm just going to make this equal to 2 inverse secant of x plus c. They don't have f of x equals to anything or f prime of x equals to anything. It's just that part like this, 2. And so you're like, well, what is that equal to? Is that f prime or is that f? And of course, your teacher's going to pick the wrong one to get you to pay attention, all right, when they grade. All right, let's keep moving on. So f prime of x is negative 4/3 1 plus x squared. So you go, well, let's look at the bottom. So I've got this, here's my negative, here's 1 plus x squared down here, and what I don't have is that 1. So you can say this is negative 4/3, or let's factor out the 1 and leave it negative 1 over 1 plus x squared. All right, so that my pattern, this pattern of the negative 1 over 1 plus x squared is intact right here inside the parentheses. So this would be 4/3 plus c. Okay, doing all right? Now there's not a whole lot we can do with these until we can get to where we have something like maybe what's going on right in here is a 16x squared as opposed to just an x squared, but we don't know how to do that yet until we get to the next video. So this is really kind of short and straight to the point. Gets more complicated when we get into how to use the substitution to UDU principle. All right, so let's keep moving on. Now, in an earlier video, and I'll see if I can get all these links in there, we learned how to take the derivative of these hyperbolic functions. Okay, and I put both the typical trig functions on here. Remember, these are based on a unit circle. You followed around a unit circle. These are based on a hyperbola. That's why they call it hyperbolic. So they trace around a hyperbola. These over here are actually the drawings of what the hyperbolic functions look like. We'll look at that in just a minute. All right. But what I want you to notice here is you may have noticed that in the typical trig unit circle functions, if it starts with a c, so the derivative of cosine, the derivative of cotangent, the derivative of cosecant, they all have a negative. And if you picked up on that pattern, that's good. Okay, it's always good to pick up on a pattern, but please notice that it's not true here. So the derivative of hyperbolic cosine is not negative sine, hyperbolic sine, it's positive hyperbolic sine. So the negatives are slightly switched. Here's the negative for hyperbolic cotangent, hyperbolic cosecant, but here the derivative of hyperbolic secant is negative. So I want to be sure and point that out to you so you don't get that misconception that if it starts with a C, it's still like that. All right. Oh, I did want to do one more problem, I think, before I go on. So I've forgotten about this one. This is a good problem. So talking about patterns, before we go on, let's back up for just a minute. This is a little bit more complicated. I forgot about this one. This is a good one for us to do before we go on to the hyperbolics. So you look this over and you go, well, I've got a 1 plus x squared looking at the bottom. So you look at the 1 plus x squared and you go, well, it's kind of like this inverse tangent, but it's not exactly. So you have to sort of be willing to play with it and reorganize it and say, well, I can't factor the 2 out, right? Because 2 is not in common with the x squared. Like here, I factored out the 4/3. So I can't factor out the 2. Just for trying it on for a possibility, the 2 breaks down to 1 plus 1, right? And then if you have this one, so here's your 1 plus 1, but if you group the 1 with the x squared, this might be kind of interesting in the fact that this is 1 over 1 plus x squared plus 1 plus x squared over 1 plus x squared. Now you can't split the x squared plus 1. You can duplicate it underneath each part of the numerator, but you can't put one part over x squared and one part over 1. That's to split up x squared plus 1 into different factors. If it's possible, you would have to use partial fractions. We haven't done that. Okay, so this 1 plus x squared over 1 plus x squared is 1. So I have 1 over 1 plus x squared. Well, I know how to do the antiderivative of 1. And 1 over 1 plus x squared is this inverse tangent. So f of x is the inverse tangent of x plus c. See, don't you think that's a good problem to go back for? It's worth going backwards, right? All right. Okay, back to hyperbolics. So remember, the trig functions you're used to are based on the unit circle. The hyperbolics are based on a hyperbola. And these are the graphs, right? We'll shrink that down where you can see it a little bit better in a minute. All right. Again, keep in mind that these problems we're working are kind of trivial, I guess you have to say, because there's really not a lot of work to them. You just find the one that's in the pattern because we don't have any more complex strategies yet. That's in the next video. All right. So we're going to go through these pretty quickly. So if you've forgotten how to do these, the derivatives of the hyperbolics, remember that we had a video in the derivatives section where we practice these, so I will link those in the description down below. And let's talk about, if I tell you the derivative of something was 3 times the hyperbolic sine of x and 5 times the hyperbolic secant of x, tangent hyperbolic of x, right? Then what we would do is we would look here and go, we took the derivative of something and got the hyperbolic sign. So to get the hyperbolic sign, we took the derivative of the hyperbolic cosine. And the 3 is a multiplier, just goes along with it, all right? Then we took the derivative of something and got hyperbolic secant x, hyperbolic tangent x, and we want a negative, is what we would have done. And we ended up with a positive, so we have another negative, if that makes sense, because you would say this is negative 5 hyperbolic secant plus c. And remember to title it f of x, not f prime. Don't forget the plus c. Students say they can hear me all the time on the test. They're taking the test, and I go, don't forget the plus c. All right, let's do another one. F prime of x is the hyperbolic cosine of x plus the hyperbolic secant squared of x. And I'm going to tell you an initial condition, f of 0 is equal to 3. Let's see what we can do here. So f of x, what did you take the derivative of to get the hyperbolic cosine? Here's the hyperbolic cosine. So you would have taken the derivative of the hyperbolic sine. And to get the hyperbolic secant squared, you would have taken the derivative of the hyperbolic tangent. There's a squared up here. All right, plus c. All right. Then they say, all right, now f of 0 is equal to 3, so I can apply that. 3 is equal to the hyperbolic sine of 0 plus the hyperbolic sine of 0 plus c. So let's look at these drawings over here. All right. So we're looking for the hyperbolic sine, and that's right here. And we're trying to figure out what the hyperbolic sine of 0 is. And so the hyperbolic sine of 0 is 0. And then we want to know what the hyperbolic tangent of 0 is. And this is the hyperbolic tangent of 0 is 0. That's helpful. I like zeros. Makes the math easier. Plus 0 plus c equals 3. So c is 3. So the original function is the hyperbolic sine of x plus the hyperbolic tangent of x plus 3. All right, so I'm going to shrink these down a little bit. And this is the hyperbolic cosine, hyperbolic sine. I got these off the Desmos, but you can hardly see what's written up there. All right, by the time you shrink it down. So this is what they look like, in case you want to take a screenshot or see what's going on there. Okay? All right, moving on. So then we have to be able to do the inverse hyperbolic cosine and sine and all that wonderful stuff. Again, if you've forgotten how we took the derivative of these, there's an earlier video that goes over all of these. Check the description out. Also, remember in the description, there's probably not a whole lot because there's not much we can do with this. There's some practice problems for you to deal with, and then links to the next video. I can guarantee you on the next video there'll be a lot of problems to practice with because it's a really interesting way to talk about an antiderivative and the things that you could do. Lot of nuances, so a lot of problems because you have to practice that in order to get kind of comfortable with the entire concept. So again, what you're looking for are patterns. And you have to be careful because on a test that's not specifically dealing with this one section or homework on this one section, you could maybe be looking at the inverse trig functions because they've got squares on the bottom and square roots and all sorts of neat stuff. So be sure you're looking for the proper one. All right. Now, so if we are looking for 1 over the square root of x squared plus 1, that would be this one right here. So this would be the inverse hyperbolic plus c. If you look really quickly and you're not really paying attention, if you have, like, say, a whole formula sheet that has all of these in one place, or if you have memorized these and you're going really quickly through your mental list and you haven't tied these down really tight where there's no wiggle room inside your mental list, it's possible that you may skip or not necessarily pay attention to that square root. And see how this is 1 over 1 plus x squared, which is the same thing as x squared plus 1. You might think it's the inverse tangent, but it's the inverse hyperbolic tangent. So be careful with all these little nuances, little bitty tiny details, right? So if I tell you you took the derivative of something, you would say, all right, so I need an x and a 1 minus x squared, and that looks like this one right here, okay? And I'm trying to make it look like that pattern. So if I looked like that pattern and I have 5, 6, and I want negative 1 over x square root of 1 minus x squared, then this would also have to be a negative because remember it started off positive. So you have the negative that the pattern wants over here and the negative to make your original pattern. So this is negative 5, 6 hyperbolic inverse hyperbolic x plus c. Okay? Now, these two, if you look at the inverse hyperbolic tangent and the inverse hyperbolic cotangent, right? They look like they're the same, and you're thinking, well, maybe that's an accident or something, but they are the same, except their domain's not the same. So for the inverse hyperbolic tangent, its domain is the absolute value of x has to be less than 1, which basically means you're looking at fractions or 0. And here, the absolute value of x has to be greater than 1. And by fractions, I mean, you know, um, not like 17 thirds, which is bigger than 1, but, proper fractions where it's less than 1. All right. So those two, just in case you run across this again, right now, with just being restricted to this concept of just the beginning introduction to antiderivatives and not differentiable insides, for lack of a better word. You remember on the chain rule, we would say bring the power down, leave the inside alone, take 1 off the power and loop back in, that inside part. All right, when we first started taking derivatives, we didn't have the chain rule, so it just had to be the power rule or, something very simple, x squared, x cubed, x to the negative 1/2. But it couldn't be something like 2x plus 3 squared because we didn't know about how to loop back in and take the derivative of 2x plus 3. So these are all really straightforward, really cut and dried. Not very interesting, not entertaining, um, just kind of there, right? In the next section, in the next video, we're going to do the chain rule backwards, for lack of any other thing, the UDU method. And we're going to do that. And I think because some people do not do these types of functions in their course, I'll probably make that into 2 parts as well and talk about the kind of more commonly used forms, and then make a separate video for these with the hyperbolics and the inverse trig functions. Okay? All right. So just a few practice problems in the description for you to try, because again, these are just pattern recognition, is pretty straightforward. Then lots more problems when we get to the next videos, and I will see you at the next videos.